Yeah, in the today class, what we will do, we'll continue about OSI layers where we stopped yesterday. So yesterday we discussed about couple of topics like all the acronyms and also full forms. And also we started networking concepts. Under networking concept, first topic is OSI layers. So OSI layers, why we will use? It's mainly for the end-to-end communication or peer-to-peer communication. This particular process is defined by ISO in 1984. So as per OSI layer, so we have 7 layers are there. Those layers from top to bottom are application layer, presentation layer, session layer, transport, network, data link, and finally physical layer. So already we completed yesterday. So application layer. And so coming back to sixth one, it is presentation layer. So we stopped in between this one. We did not complete yet. So we'll start now from there where we stopped yesterday. So sixth one is presentation layer. So presentation layer, what exactly it will do? It will convert one form of the data into another form of the data. So what are the features are included in the presentation layer? So encryption or decryption, that is first feature, and also encoding or decoding and data compression. So couple of other things as well. Examples it will fall under those one form of data will be converted into another form of data. Those things are example binary to decimal and also decimal to binary, or else hexadecimal to binary, or hexadecimal to octa, and so on. So yesterday we completed one more topic is encryption decryption. So what is meant by encryption? So encryption is nothing but it will do conversion of the plain text data into encrypted data using symmetric and asymmetric cryptography algorithm. And the main thing is very important thing what you have to remember, password or key. Using that password or key, so it will encrypt the data or it will decrypt the data. So forget about cryptography algorithms. So but main thing what you have to remember, you have to remember the password or key is a must for encryption side. So that what will happen? So encryption it will happen. So that entire process is called as encryption. Opposite to encryption is decryption. So what it will do, it will convert whatever encrypted data it is there using the key, it will decrypt and it will make it like a plain text or clear text using some of the algorithms. So those algorithms are once again symmetric and asymmetric. So those things we can discuss later. So here both encryption decryption are bidirectional. Why? Because we are encrypting and also we are decrypting. So that one we can call it a bidirectional. And also we have seen about hashing. Hashing, it's only one way. Reverse is not possible mathematically, but encryption side, so reverse is possible. So that is the first thing we discussed. So there I stopped. So from there we can continue. Next one is encoding. So what is meant by encoding? So same thing, it will convert one form of the data into another form of the data, encoding also. What exactly it will do? Mainly for why we have to convert one form of the data into another form of data, for usability and also for readability and also for user point of view understandability purpose, we will use encoding or decoding. So encoding decoding also bidirectional. So what it will do, it will convert one form of the data into another form of data. For example, maybe so converting of audio file into like a video, maybe into another form of the file in the similar way. So data compression also will fall under the encoding. So for example, one of the file contains maybe 100 MB. If I want to compress that particular file size to, for example, 80 MB, I can use using zipping part. So compressing of that file. So example, data compression also will fall under the encoding only. So meaning here, we are converting one form into another form. So how we can define this particular encoding or decoding? It can be used for readability and usability and also for understandability from one form of data into another form of data. Example, message into audio or video files, or data compression. So these are the couple of examples for encoding and decoding. So once again, encoding and decoding, it's a bidirectional. Reverse is possible. Whatever we are encoding, we can decode as well. Couple of encoding technologies, especially on the application side using a payload. So binary 16 to binary 32, and also base 32 to base 64. Whenever any packet, not packet, payload. So payload is traversing in the application side. So we can encode the data in the URL and also using HTTP request and also HTTP response. There we can decode and we can see what type of data he has sent it and how the backend web server or database server will respond back. So that entire process we can use couple of tools like Burp Suite and also Kali Linux and other tools are there. So for encoding and decoding as well. So that is about encoding and decoding. It's a bidirectional once again. Note I'm saying encoding is bidirectional. So that is about encryption and encoding and decoding part. Next one is the data compression. Already I said what is meant by data compression. So compressing of the data. So before compressing of the data, it's one form, and after compressing of the data, it is another form. So one form of the data we are converting to another form of data. For example, as I said previously, so maybe 10 MB file, if I want to reduce the size of the file, so 10 MB is one form. So to zip into that particular file to 9 MB or 8 MB, so that is another form of the data. So data compression also example for so presentation layer, and also we are converting one form of the data into other form of the data, compressing of the data. And also we have ASCII to EBCDIC and EBCDIC to ASCII. So this is long back when C language is entered into our basic or COBOL. So around 1984 to till 1995, in between those particular time period. So we have basic and COBOL, all those programming languages, it's initially invented. So in that particular scenario, what we have done, so American standard we converted into European standard. In the similar way, European standard we converted into American standard. So that particular process we are converting from American standard to European standard, vice versa, European to American standard. That is called ASCII to EBCDIC. Okay. So one more example I will give. ASCII to EBCDIC, American Standard Coded Information Exchange, in the similar European Binary Coded Information Exchange. So that is the main difference between these two. So this one form of the data is we converted into another form of the data. Same way, so for example, decimal to binary. So now decimal number. So we can take one of the decimal number. The decimal 10 number may be 12. So if you want to convert this decimal number to binary, what we have to do? Anyone? What we have to do if you want to convert decimal number to binary number, so that computer can understand?
8401 if you do will get it. We have to convert with the 8401 format.
Yes, that's correct. So 0101 format we have to convert. So binary is nothing but 0 and 1. So here binary means 2. So we have to do LCM with 2. So here first 2 I am keeping here. 2 6 are 12. So 6 and so dividend will come as a 0. And once again, so 2. So 2 3s are 0. Sorry, 6 and 0 will come once again dividend. And once again 2. So 2 ones are 1. And dividend, how much it will come now? 1. So how we can represent now this one binary? So we have to take from so bottom to top
0 0
1 1 0 0.
00.
So this is called as a binary number. So if we're converting so decimal number of 12 to binary number 1100, it will come. In front of that one we have to add 4 zeros as well. Why? Because always we have to represent this particular entire form of the code as a 0, so 8 bit always. Okay, because IPv4 is a part of 32 bit. So before in front of this one we have to add 0 0 0 0 1 1 0 0. So this is the overall conversion of the respective 12 decimal we are converting into binary. So this is the way we can convert into different formats. Now I converted one decimal number 12 to so 1100 in the similar way. So binary to decimal, so binary to hexadecimal, hexadecimal is nothing but 16, and binary to octa, octa is nothing but 8. So many formats we can complete or convert. So that entire thing, which layer it will do normally? Presentation layer. So that's all about overall presentation layer. So I am removing this one. Now data format. So what is the data format in the presentation layer, and how it will convert one form of the data into another form of the data? Our protocol data unit is data only
Data.
and attacks. So always remember seventh layer and also sixth layer and fifth layer. All these three layers almost equivalent to so one layer only, that is application layer. Whatever attacks it will appear in the seventh layer, same attacks it will so appear in the even presentation layer and also even in the session layer as well. So once again I'm repeating the attack names are OASP, top 10, SANS, top 25, man in the middle attack. So all those attacks once again will fall under the so presentation layer. So so why I'm converting or why I'm keeping these attacks are same as it is. So tomorrow topic is TCP IP layers. So in the TCP IP layers, what we will do normally, whatever first three layers are there, so nothing but application Likita, yeah, application layer, presentation layer, and session layer. These layers we will convert into application layer itself. Meaning what? So fifth and sixth and seventh like a hand in hand. So whatever attacks it will appear in the application layer, it is applicable to presentation. In the similar way, whatever attacks are appearing in the presentation, same thing it is applicable to session as well. So that is about overall attack wise. So that's all about overall presentation layer. In this presentation layer, what you have to remember and what is the interior question. So encryption will fall under which layer? So presentation layer. So what is the difference between encryption, hashing, and encoding? So encryption is two-way function, hashing is one-way function, and also encoding also two-way function. Encryption reverse is possible, hashing reverse is not possible, encoding reverse is possible. So and also once again, encryption is nothing but the process of converting plain text data into encrypted data using some of the algorithm. Along with that algorithm, we have to use password or key. That entire process we can call it as encryption. I have shown yesterday already HDFC Bank example, how the encrypted channel it will form in between end user browser versus to backend web server of the HDFC Bank. So that is about encryption, and the hashing is digital representation of the file or so converting of the so one of the plain text data into combination of both characters and numbers is called as a hashing. And finally encoding. So encoding is so converting one form of the data into another form of the data so that user can be understandable and also user can be readable and also user can be so it's a very user friendly. So that is about overall encoding. So that is the way maybe you can expect the entire equation, or else what is the main difference between encryption and hashing? So most of the interviews we can expect this question. Okay. So that is about so presentation layer. Let's go to fifth layer. So layer number fifth and the layer name is session. So session layer, what exactly it will do? Managing of the session. So for example, maybe you are making a WhatsApp video call. We have options like not only video, but also we can speak as well. That is nothing but audio. So here video is one session and also audio is another session. So which layer it will do that particular thing? WhatsApp is application, and whatever call you are making it as a session layer, And so here video is one session and audio also one session. So that is the reason always, as I said previously, application presentation session is like a hand in hand always. So it will manage the sessions. Not only just it will manage the session layer, it will provide the additionally so authentication. Example, whenever you are installing the WhatsApp or PhonePe or Google Pay, you will register with the respect to your mobile number. So then it will ask OTP and you will provide the multi-factor authentication as well, right? So after that, your identity is already verified by the respective backend WhatsApp server, part of the metadata in the Facebook side. Okay. So now authentication already it's completed by the backend WhatsApp server. So additionally, whenever you are making a call, so authorization already completed by WhatsApp server. So total three things it is doing whenever you are making a audio call. One is already registration is completed, part of the authenticity of the respective end user, nothing but identity of the user. That is as per CASSP, it's a who am I, and also backend WhatsApp server part of Meta. So it is already completed authorization. Can you make it authorization? Whoever is already part of your friends list and whoever has the contact. So that is authorization. Here it will verify who are you as per CASSP. So those things it is completed. Now you are making a call. As I mentioned previously, video. Video contains combination of both audio and video. Also we can speak and we can see each other. So total three things it is doing. One is session management, second one is authentication, and third one is authorization. So that is about overall session layer. So what are three things it is completing? First, what is mean by definition of the respective session layer? Managing of the sessions will be done by session layer. Under this one, so features are session management. Second one is authentication. Third one is authorization. So not only just WhatsApp, take anything. So maybe in the email, I'm attaching one of the audio clip and also one of the video clip. So I'm sending one of the email to you as a sender and recipient. And so email you will receive if I'm providing correct address, all the verification will be done. So audio, it will make it like a one of the session to traveling from source to destination or sender to recipient. In the similar video, it will take another session and you will receive it. So it's not only just think, don't think like it is applicable to only part of the, so any social networking websites, it's applicable to any applications. Okay. So session management meaning here managing of the session or session management once again. And authentication already we discussed, providing the credentials and verifying the identity of the end user. So that is called authentication. And authorization, granting or giving the permissions. So this one will be done by backend server. So that is about authorization. As I said previously, so as per CASSP and also European Council and ISACA, so what they have done, so they define couple of things. So authentication is nothing but who am I, and authorization is nothing but here who are you. So this already we discussed part of our initial discussion related to cybersecurity definitions. So now coming back, what is the data format in session layer? It's a data only. And what are the attacks? It will appear same as it is. So WASP top 10, SANS top 25, man in the middle attack, all those things will fall under the session layer as well. Okay. So that is about overall session layer. This is also one of the important layer. as part of the OSI layers. And I forgot to say yesterday one thing. So OSI layers, another name is OSI reference model. So why I'm saying this one, in one of the interview, so in the class I explained about OSI layers only. I did not give the okay so term as OSI reference model, and that particular person is got confused. Maybe OSI layers is different and also OSI reference model is different, but both are same. Okay. So that is about overall session layer. And next one is,
RK,
yeah,
I have a
please.
one doubt.
Yeah, please.
So basically, you said about session hijacking, right?
Yeah, session hijacking also will come under here. Yes.
Right. So in the first one, in the application layer, you said
Everywhere it will
there
come
would
same
be,
thing. Yeah.
but we are managing sessions here. So why are we placing that session hijacking in a presentation and application layer?
Yeah, same thing. It's a good question. As I said, if we are going for tomorrow topic, we have TCP IP layers. So if
Hmm.
you're combining application and presentation and session, it will come as application layer. So whenever you are accessing any application, so these three layers will fall under like a one layer only, that is application layer. So whatever application it is doing, so it has a subset of the presentation and also it is subset of the session. So that is the reason all these three things will fall under these three layers. Okay.
So basically, when we are talking about this 7 layers, and that is a model which we have been, I mean, at present we are working on those models, right? So these three are combined to form a single layer over there.
Yeah,
But
indeed. Yes, you are right. So advanced, okay, so model of the OS layer is TCP IP reference model.
hmm,
So so these TCP IP reference model, whatever attacks will fall under the application and presentation and session also will fall under the same as it is. So because these three layers were combining, that is advanced one. Okay. So now whenever you are accessing any okay website or any application, take example
hmm,
Gmail itself. So it is
hmm,
not only applicable to application, whatever email you are sending via Gmail, but also it is
hmm.
applicable to, so these three layers combining together basically. So then only session will form, and also along with presentation it will form in between. So these three layers. So that is the reason these attacks I put under the all those three layers.
So normally, when we are talking individually in OSI layers, then we can't say this directly.
No, we can say directly. It's okay, no problem. You can say directly. Even session hijacking also will fall under the presentation and application. Why? Because encryption. What do you mean encryption? So meaning here you are accessing the website in between the web server and
Hmm,
you. So session is
hmm,
forming. So in the
hmm,
similar way, WhatsApp call you are doing. So one of the session is forming. Even in the application layer also, whatever token you are sending using WAUth 2.0 or OpenID Connect and SAML
hmm.
authentication mechanism, session will form. So you can say session hijacking for three layers, no problem.
Okay, okay.
Clear?
Yeah, yeah, got it.
Okay. Next one, fourth layer. So transport layer. What transport layer? This is also one of the important layer. It will do so many things basically, mainly for the delivery in between source to destination or peer to peer. What exactly it will provide? It will provide error free control, nothing but errorness, and also it will provide data flow control. So that is the importance of the transport. Okay. So what is mean by error freeness and what is mean by data flow control? I will explain. It can provide data transfer between source and destination, and also using error free control. Error free control means without any errors, and also data flow control. So where the data flow control, it will happen in between source and destination. So now data format is segments and also datagrams, and couple of attacks it will fall under this particular layer. TCP flood attack, sync flood attack, UDP flood attack. So these are the couple of attacks will fall under the transport layer. What is my TCP sync flood attack and sync flood attack and UDP flood attack? We'll discuss part of our network and cyber attack. Separate concept is there. So now we can discuss about what is mean by, okay, so segmentation. It will provide segmentation. There are three features will fall under this one. One is segmentation. Second one is error-free control. Third one is data flow control. So these are the three controls will fall under all. These are the three features are included part of the respective transport layer. Now, what is meant by segmentation? So we will do network segmentation in the on-premise, in data center wise, and also we will do network segmentation in the cloud wise as well. So network segmentation meaning here converting the bigger data LAN into smaller LAN for users, servers, and databases. In case our company belongs to product development company or engineering team is existing part of the R&D team, in that scenario we can segregate. So what a product development we are doing, example take Honeywell or Robert Bosch or maybe so Philips. So all those companies will fall under the product based companies, for example. So they have the product development company and also they have product developers and application developers. So they have mobile developers and they have part of the SDLC life cycle. So here what is meant by SDLC life cycle, you know already. So here requirement phase, design phase, development phase, testing phase, and finally release or operational phase or general availability. So now whatever access we are giving to the developers, part of the SDLC life cycle related to development, we should not give the same access related to testing environment. So for testers, we can do one segmentation as a LAN and they should not touch our environment. In the similar way, whatever so environment we are taking to software architects, they should not touch by the respective developers and testers. So same way, whatever development environment we are giving to development team, so that particular environment should not be touched by respect to testers and software architects. So this is the way we can do the segmentation of the LAN part of the IP addresses. For example, 10.10.0.0/16. So 2 power 16. So it will come around 65,536 or 535. So those many IP addresses we are converting for product developers. So now couple of IP addresses I will assign to LAN segmentation for development team. For example, maybe out of 65,535, 30,000 belongs to development team and 1,000 is belongs to, okay, so respect to software architects. So remaining how many IP addresses are available? So 31,000 are already completed. We have remaining 34,535. Those many IP addresses will assign to testers. So this is the way we are segregating and we are providing the IP address LAN related segmentation to, so respect to design team, development team and testing teams. Okay, that is called IP address segmentation part of the LAN. Now here we are discussing about data segmentation part of the transport layer. So how this particular data segmentation it will happen part of the transport. Why? Because it can provide data transfer between source to destination or sender to recipient, and whenever we are sending the data, previous example whatever I given related to IP segmentation or LAN segmentation, and this particular segmentation is a data segmentation. For example, maybe you are sending, okay, so in the WhatsApp, RK today is there any class? Okay, so now so this is the bigger sentence of the data. So it's a one meaningful sentence basically. So today is there any class or not? Okay. So that is about overall sentence. So here when the larger segment of the data can be converted into smaller chunks of the data. So it's a meaningful sentence now. So now what transport layer it will do for each and every segmentation it will do related to small. One is RK is one segmentation. Next one is today is one segmentation or segment, sorry. Is one segment. There is one segment. Any is one segment. And also call is one segment. So this is the way how the bigger data can be converted into smaller data. And each and every data we can call it a segment. Every segment has a segment ID and also source port and also destination port and acknowledgement number. So this is a transport layer. I can show right now directly TCP IP packet as well, or TCP packet. So this is the TCP packet. No, this IP packet, sorry. So this is the TCP packet. Can you see my screen by the way?
Yes.
Yes,
Yes,
sir.
sir.
Yeah. So this is the transport layer. Whenever you are sending any data, so each and every TCP packet contain so version, length, type of the service, and also total length, identification of the TCP packet, flags of the TCP packet, and also fragment offset, and also we can see time to life, protocol, header checksum, source and destination, and everything. So this is the way. So this is first one is IP packet. This IP packet first one, and TCP packet is down one. You can see TCP left hand side. I'm not sure whether it is visible in your mobiles or not.
Yes, sir.
Okay. Yeah. Yeah. Directly I went to TCP packet. So this is TCP packet basically. So one is total 32-bit number of the TCP packet. So every segment has a source port, destination port, sequence number, and acknowledgement number. Along with this one, even it has a data offset. It is nothing but data, whatever we are transferring. So just now I given one of the example in the WhatsApp group in our cybersecurity first batch. So you are asking a question stating that RK today is there any class or not? So that is the data. So that data now what transport layer it will do? It will convert that bigger data of the chunks of the data into smaller chunks of the data like RK is one segment and every segment has sequence number and also acknowledgement number and source port for communicating purpose, destination port, and RK is the data here, and it will use couple of flags here. Total 6 flags are there under TCP. Okay, whenever you are sending any message, those flags it will verify whether so respective whoever is a part of the WhatsApp group they received or not. So those flags it will enable, and also what is the time of the size related to window, and what is the checksum of the respective packet. So whether they checked or not and it's verified or not. What is the severity of the respective urgence of the packet related to transport for delivery, and options and padding related to packet, and finally data. So this is the way how that particular message you are sending RK today class is today is there any class or not. So this is the way that packet can be converted larger chunks of the data into smaller chunks of the data. Why I'm saying this one now, each and every segment has a now source port, destination port, sequence number, and acknowledgement number. So in such scenario, go back to our scenario now. So here now RK is nothing but here sequence number. One sequence number will be 1 and acknowledgement number will be another one. In the similar way, source port and destination port. So why we have to open this one? So then only it will do the communication and we can receive the communication. In the similar way, so today, so sequence number 2 and acknowledgement number 2. So same thing, source port and destination port is sequence number 3 and also acknowledgement number 3, and also there sequence number 4 and acknowledge in such a way that bigger data can be converted into smaller data. So that particular data conversion, how is it possible? through transport layer using the feature name is called as segmentation. Okay, now how we can define this one now? One second, guys. Hold on a minute. Sorry, guys. Am I audible?
Yes, yes,
Yes, you are
fine.
audible.
Okay, thank you so much. Yeah, so how we can define now this one? The larger chunks of the data or the larger data, that is also fine, can be converted into smaller data is called as segmentation. Every segment has sequence number, acknowledgement number, source port, and destination port. And along with that one, we have flags as well. So that is called segmentation. So next one is second one.
Could you please wait for a while so that we can note it down?
Sorry.
Could you please wait for a while? We can note it down. That's what.
But already you have access to this particular sheet, right?
Yes, yes, yes.
Yeah, you can. Yeah, meanwhile, I will draw the diagram for error control.
Please, thank you.
You're welcome. So now what is meant by error control here? Same concept. So now here in between sender and recipient, so now as it is, whatever I given example just now in the WhatsApp group itself. So is there any class today or not? So now every segment has a sequence number. As I said, acknowledgement number as well, source port and destination port. Now is one segment and there is one segment. In the similar, any is one segment and call is one segment. Today class, sorry, not call, class today or not. So these are all the couple of sequences or segments. Now is you can consider as a one segment, there you can consider as a two, so 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Yeah, is one segment, there is one segment, any is one segment, class is one segment, today and are and not. So those are the segments now. So this is the way, if I'm sending in the WhatsApp part of the transport layer, whoever is part of the team or group, they can see and I will respond back. Yes or no. Okay. Now, if you don't have the proper sequence number, and so errors are occurring in the respective sentence, for example, in the recipient, you have sent an email or you have sent an WhatsApp group. So this is the sequence it has to come, but unfortunately, recipient is received 6, 3, 7, 2, 1, 5. 4. So now what is meant by 6 here? What is mean 6 here?
Or
Or.
Or
What is mean 3 here?
any.
Any. What is mean 7 here? Not.
No.
Or any not. Is there any meaningful sentence here? Whether opposite person
No.
can understand?
No,
sir.
can't.
No.
Yeah. So that errors can be rectified by the respective transport layer. That is called error-free control. Whenever any data is traversing from source to destination without any errors can be done by our transport layer, so that meaningful way opposite person can understand and he can read it, and according to that one he will acknowledge it as a feedback or he will respond back. So that error freeness or error controlness or errorness can be done by our transport layer. Okay, so go back here. Then how we can define this one? In between source and destination, whenever any data is traversing, transport layer can be provided by error freeness without any errors in the data format. So that is called error control. Okay, so that functionality also will be done by transport layer. Next one, flow control. So flow control also has another name. So that is called data control. So what is this flow control or data control? Basically, mainly for the data rate. How the data rate can be measured? So it's for the bytes per second. That bytes per second may be kilobytes per second or megabytes per second or gigabytes per second or picobytes per second or terabytes per second. Transfer rate, whenever we are saying, always we have to measure with the respective time. So here, so data can be measured using the, so obviously binaries or bytes. Then rate can be measured by time. So now data transfer rate, data here bytes, rate is time. So bytes per second or bytes per minute also. So in the similar way, kilobytes or megabytes or gigabytes or picobytes and so on. So this is the way. So data transfer rate we can measure. Okay. So data along with the time, that is called data transfer time or data transfer rate. Sorry, data transfer rate. Now, whenever you're transferring the data, for example, you're copying couple of files. As I said several times in the class, so transferring from SQL database to PostgreSQL database, all the data, so that, so PostgreSQL database is my new database, and existing SQL database I want to do decommission. I want to do shutdown. Okay. So that is in that scenario, what we have to do. So we have to take care of the respective, so transferring of the whatever data it is existing in the SQL database from existing database to new database name is called as a PostgreSQL database. Or else simple words, forget about SQL or Postgres and so on. Maybe you have your mobile and you have your personal laptop, and so you went to some of the pilgrim visit or maybe travel visit and so on. You clicked on the couple of pictures or you took couple of videos. Okay. Now in that scenario, so this is example, take your laptop, and this one you can take example your mobile. So as I said, you went for any traveling, or maybe you went to any pilgrim visit site related to temples and so on. So you clicked on the couple of pictures or you took couple of videos. Now you want to transfer that particular data from mobile to laptop or else laptop to mobile, vice versa. Now, so laptop RAM size, it is 16 GB per second. So this is what data transfer rate it is accepting by laptop. and mobile data transfer rate is only 8 GB per second. Okay, so this is the data transfer from mobile side. Now you are copying the files from laptop to mobile or else from mobile to laptop. So both the options. Now, for example, whatever photos are there or videos are there from laptop, you are sending the respective photos or files or videos to mobile. Now, so what is the laptop maximum capacity or data transfer rate? Here 16 GB per second. Whether mobile will accept? Whether mobile will accept?
No, sir.
Why?
No,
Because it's
the
accepting
limit is
LTS
8
the 8 GB per second.
Exactly, that's right. So mobile side only data transfer rate maximum capacity only 8 GB. If it is sending, okay, so 16 GB, how it will receive it? For example, maybe your weightlifting capacity 100 kilos. So you can lift the your okay 100 kilos at a time. But if I give 200 kilos, can you do weightlifting at a time?
No, sir.
No, no.
It's not possible because it's already crossed the maximum capacity of the weightlifting. Now, what will happen in between these peer-to-peer devices or laptop to mobile in this scenario? It will do the exchanging of the communication. I can't accept that much particular data transfer rate, whatever you are sending. Can you please reduce the data transfer rate so that I will receive it? In such a way, backend, it will do the communication part. Now, what maximum capacity it is there, it will send that much capacity. So what is the maximum capacity? So 8 GB. So that is about, so one directional. Now bi-directional also we will see from mobile to laptop. So mobile is sending only 4 GB per second. So here maximum capacity will accept 16 GB also. You are sending data very slowly. I can accept up to 16 GB as well. Whatever maximum capacity it is there from your side, you can send it. In such a way, negotiations will happen between these peer-to-peer devices. Finally, whatever maximum capacity it is there or transfer rate it is there from the respective, so opposite device or peer device. So negotiations and also communications it will exchange using hello messages and also acknowledgement messages and sequence messages and so on. Finally, it can send the data transfer rate as 8 GB per second. So this entire process, now what it is doing, flow control. So in between these peer-to-peer devices, so negotiations are happening, control it is happening related to data transfer rate. So the data transfer rate, so how it is doing, complete it's based on, so whatever, okay, so negotiations are happening in between the devices. So which layer it will do that particular data control or data transfer rate control or data flow control or data flow control. So transport layer. Okay, so this is called data flow control. These three features will be done by our transport layer: segmentation, error-free control, and data flow control. Okay, so go back to our sheet.
Sir, the entire sentence, as you said, is there any class today? Why don't it travels to destination in proper way? Why segmentation? Why flow control?
Yeah, so yeah, it's a good question. We have different types of flags are there. TCP flags. Those flags are synchronization, acknowledgement, urgent, push, and also we have reset and finish. So for example, there as a urgent capacity, the packet wants to transfer very quickly. So in that scenario, whether it will store whatever it is there in the buffer or cache of in between source and destination, whether it will see. For example, one of the person met an accident. So it's a very emergency case and he wants to visit to the respective hospital, whether he'll follow the taking the respective token system and whether he will wait for the to take care of the treatment.
It's not good.
Yeah, same as it is here. Whenever any TCP flags are enabled, in between buffer or cache will not it happen properly. So couple of times what will happen? So wherever the sequence number and also where urgent priority, push priority is there, those packets it will receive very quickly. So that time what it DCP transport layer it will do, it will make arrangement in the proper sequence. Is it clear?
Okay.
Yeah. So it has to re-verify what are the packets are existing in between source and destination, which packet has to high priority and which packet has to give the low priority. So in case urgent and push is given high priority, obviously it will not follow any sequence. For example, as I said just now, one of the practical example, one of the person met an accident. So hospitals will give always high priority without, even though they are following protocols and rules and regulations related to token system. Why?
Like
Because it's an emergency case.
yes.
Yeah, same as it is.
How it can understand, sir? It is urgent or priority.
So now flow control.
RK sir, as he asked, I mean, this judgment can be done by this transportation layer, or while sending the data, can we segregate that?
No. We cannot segregate that one. It's completely backend process. Whatever we are discussing, so we don't have any user-wise communication at all. So everything is a backend process. From front end we can't see. So we can see the data where we can see once you are doing the packet capture in between source and destination. For example, I am sending one of the email to you, and now in between you and me, I have to do the packet capture. After doing the packet capture, what we have to do? We have a couple of analysis tools related to packet capture. Those tools are Wireshark. And also we have one more tool name is called Microsoft Network Traffic Analyzer. Once you are taking whatever mail I am sending to you or you are sending to me, I can take the packet capture. Now I can go and I can do the analysis. So how the sequence it went and which flags it is enabled, and also whether TCP three-way handshake is completed or not, and which packet is high priority. All those analysis can be done. So completely packet using Wireshark analysis tool or network traffic analyzer or Microsoft network traffic analyzer. So that is maybe day after tomorrow class.
Okay, sir. For that case, so we need to capture the logs and then we can put the logs into that analyzer. So based on
Not
that,
logs, not events. So it's a packet.
Yeah, packet capture, like trace route will execute from the servers.
Yes, data. That's correct.
Okay, sir. Thank you.
Welcome. Whenever any data is traversing in between source and destination, data transfer rate or data flow control between peer-to-peer devices will be done by transport layer. Okay, so that's all about overall transport layer. It's not completed yet. So we have a lot of other topics as well in the transport layer itself. Couple of example protocols, it will fall under the transport layer. Example protocols are TCP and also UDP. So TCP full form is transmission control protocol. UDP full form is user datagram protocol. In the transport layer, already we discussed this topic yesterday. So in the transport layer, we have a couple of connection establishment and also connection closure. So whenever any user is accessing any other application in the transport layer wise, so TCP three-way handshake, TCP two-way handshake, TCP five-way handshake, it will happen. So now we can discuss about those three. What is meant by TCP three-way handshake, TCP two-way handshake, TCP five-way handshake, and finally, what is the difference between TCP versus UDP? Then only will complete overall transport layer. Okay. First one, TCP three-way handshake. So whomever I will ask now, those people has to give the answer. And I'm giving request. Other people did not respond. Hope everyone is coming from day one onwards. These classes. So, and especially yesterday and day before yesterday, is for, I'm not sure who is this one. 82187912002. Who's that? 82187912002. Okay, that's fine. Next one, Amala. Amala, are you there? Hello. Next one, Akhil Naidu. Akhil, are you there?
Yeah, yes, I am.
Yeah, what is meant by TCP three-way handshake?
TCP three-way handshake is like whenever we are sending any data, initially it will be sharing the synchronizer packets to the receiver. And from there, we will be receiving the acknowledgement and later we will be sharing with the sync acknowledgement towards the data, and the establishment of connection will be happen from there.
No, you are wrong. You said reverse way. Almost you are there, but you said reverse way. So first one, whenever we are sending data transfer in between client and server, so or may peer-to-peer, first it is synchronization request, and server will respond back sync plus acknowledgement. You said acknowledgement, that is wrong.
Yeah, sorry, I missed that actually.
Yeah.
Sync this acknowledgement, later we will be sending the acknowledgement, and
yes.
connection
Last
will
one
be
is acknowledgement, and final connection will be established.
yes, and the
You
data.
said the two and third step is wrong, but anyway, really
Yeah.
appreciate for that one. Thank you so much. Yeah, so this topic already we discussed. So in between client and server, what will happen are peer-to-peer, or maybe server and database, or end user and application, and so on. So there are three different types of requests it will send and it will receive. First one is sync plus acknowledgement and acknowledgement. So that process, what it is happening between peer-to-peer or client and server, so that entire process is happening. So total three ways, that is called TCP three-way handshake. But don't say in the interview point of view, okay, sync or synchronization or synchronization plus acknowledgement or acknowledgement. I have seen couple of students are saying or candidates are saying, so these three sentences only, sync plus acknowledgement and acknowledgement, it will not work out. So you have to give the full and proper sentence, how it will happen and what it will happen. Take example also, one of the practical scenario. Maybe you are withdrawing some of the money from ATM. Maybe you are searching some of the address in the, okay, so respect to Google in the Gachi or maybe Kondapur, Hyderabad. So take one of the example. For example, in this scenario, so you are going to search query in the search engine of the Google, and you are giving the address of the, okay, Google address in Hyderabad location. So that is synchronization request. Now what Google server will respond back for whatever query I raised now. So it will display the different types of addresses for Google company and also other locations as well. But I asked about only Hyderabad location. So it is nearer to Kondapur or Kotta, whatever. So or Shilparama. So then I can choose that particular one as a synchronization plus acknowledgement. And finally, I will say thanks to Google. But I never said thanks to Google, but it's a backend process. So in such a way, you can take one practical example or day to day. So what a practical our life it's going on, practical scenario it is going on, so that so they will think like, okay, this candidate has a practical experience as well. So he's always correlating with practical. Okay, so that way you can give one example as well for anything, whatever you are discussing, whatever you're explaining. So coming back, in between client and server, client will send synchronization request to server. server will respond back with sync plus acknowledgement, nothing but synchronization plus acknowledgement, nothing feedback as well. And finally, client will give feedback as a acknowledgement. So that entire process is happening in 3 ways. So that's why it is called TCP three-way handshake. Okay. So this is for the connection establishment, and also we are getting the message or data. So TCP three-way handshake can be used for connection establishment. Okay. So next one, TCP two-way handshake. So why we will use TCP two-way handshake? So same thing. So now I am user, I asked about Google address, same as it is you can take. So last packet it will send from Google with finish. So did you receive my final output or not? Okay, did you identify my address? Did you identify your address or not? Whatever you are searching Google company in Hyderabad location. So there it will send one of the packet form of the TCP flag. That name is called as a finish or pin. And the user will respond back, okay, thank you. So in such a way, he will respond back as acknowledgement. So this is for the connection closer. So this is the last packet. There are no other packets are there to send. So this is last packet, and so that connection will be complete, it will close. So there we can use, okay, finish and acknowledgement. Not only that one, for example, maybe you're accessing one of the website or YouTube in your maybe mobile. So your maybe data transfer is completely over. So once again, you want to establish a connection. So your last packet is sent and reset is also already completed, and you have to do data recharge once again, and it will start fresh connection after you are doing the recharging of the respective mobile, so that you can access once again YouTube. So there it will use different types of flags here. One is for the connection closer and resetting of the connection. Once again, new connection establishment and new connection closer. So here it will use multiple flags. So I'm repeating once again. You are watching YouTube. Suddenly your YouTube recharge it's over related to data, and you can't access. You have to recharge once again. You have done the recharge in your mobile, and once again, okay. So you clicked on the reset of the connection, and fresh connection will be established, and there is no other packets. And your last packet you will send you, and you are watching one of the movie. And finally, your connection will close, and you will close your movie, whatever it is going to complete. So that is the way. Here multiple flags will be defined, and mainly this particular thing, TCP two-way handshake. Okay, so in between user and server, or client and server, or peer and peer. So user will send the finish flag, and so respective server will respond back with the acknowledgement, and so connection will be closed. So that is the way connection will be closed in between the peer to peer. In between peer to peer, client will send finish request, and server will respond back with acknowledgement. This for mainly is for connection closer. It's a Capgemini, a Mindtree, and one more company. What is that? UST Global interview question. What is TCP three-way handshake and TCP two-way handshake? But main thing is this is very, very important. Most of the interviews we can expect TCP three-way handshake. So TCP two-way handshake can be used for connection closer. I'm bringing lot of flags here. Don't get confusion. So we can discuss these flags maybe in the tomorrow class. Now TCP 5-way handshake. So 5-way meaning combination of both TCP 3-way plus 2-way. So that is called TCP 5-way handshake. TCP 3-way handshake and TCP 2-way handshake, or TCP 3-way handshake plus TCP 2-way handshake. Connection establishment or connection closure. So that is called TCP 5-way handshake. So that is about overall how the connection will be established and how the, okay, so connection will be closed. And here we'll use two different types of flags. One is FI and finish, and second one is acknowledgement. So far we discussed about 3 flags. Those flags are TCP flags, synchronization, acknowledgement, and finish. Another 3 flags we do have. Those flags are reset, urgent, and push. Total TCP flags are 6. Those flags are synchronization, acknowledgement, finish, urgent, push, and reset. That is also one of the interview question. So that I will explain later. So TCP flags. Okay, so shall I continue or shall we see tomorrow?
We'll see tomorrow.
Okay then. Okay guys, okay, that's all for today. We did not complete yet. Okay, so transport layer, still one of the topic is pending. So that is difference between TCP versus UDP. So that will explain tomorrow. Once that one I will complete, maybe I will try to complete tomorrow overall OSI layers. Okay, so I'm going too much in depth analysis, and also there are so many topics are interlinked. For example, in this scenario itself, so TC flags are interlinked. Then only you will understand this one. And also here packets I brought in between packets and also 32-bit. So that is part of the network layer, and also routing also I defined. So that is network layer. Okay, so that is the reason don't miss out the classes. One class has an interlink with another class, then only you will understand. Hope it's clear.
Hello.
Yeah, please.
RK, as a SOC analyst, how important it is to have a knowledge on Wireshark?
Wireshark, it's one of the very favorite interview question, mainly for troubleshooting purpose. So most of the cases at the time of the interview, they can expect like, do you have any knowledge on Wireshark? So in which cases you will use Wireshark analysis? For example, maybe you are analyzing the traffic and a couple of systems or servers are got compromised, and you are not sure what is the abnormal or outbound connections are going away from this particular end user system to the attacker server, and action it is showing as a allow, and you should now to do the troubleshooting part. So where went and what is the traceability of the end user system or server or database to the respective command and control server. Now what we have to do, we have to do the payload analysis, and also we have to do the packet analysis. Then only you will understand how the packet is routing in between the end user to the respective attacker as a command and control. Not only that one, couple of times you will do the log onboarding, nothing but log integration to SIM tool. So what will happen? Logs, it will not reflecting the SIM tool. In that scenario, what you have to do, why logs are not coming to SIM tool or logs are not reflecting in the SIM tool, you have to do the fixing of that problem. If you want to fix that problem, you have to take TCP dump if it is server, or else if it is networking devices or any other endpoints, we have to take the packet capture in between the SIM tool to respective log source or data source. After taking the packet capture, now what we have to do, where is the issue? Whether issue is there on the application side or issue is there in the network side, whether packet is a dropping or packet is a retransmitted or packet is allowing. Okay, so in this similar way, on the transport layer side, in between respective SIM tool to log onboarding log source, is there any TCP 3-way handshake it's happening or not? TCP 2-way handshake, which flags are enabled, what is status of the TCP flag, and finally network interface side, is there any cable connection or physical cable connect related issues or media related issues are existing. For those scenarios, basically Wireshark is a very, very important tool, and especially L2 and L3, they will analyze the Wireshark analysis tool. Is it clear? I
Yes,
hope.
okay, clear. Yeah, clear. So it is always advantage to have knowledge on Wireshark, right?
Obviously, it's a part of our job.
Job. Okay, thank you.
You're welcome. Any other?
It is commercial tool or not?
Hello?
Sir, in YouTube today you uploaded for part 6, right?
Yeah.
But already yesterday the same video you uploaded here with the name of different name. Part 6 and part 5 the same videos.
Okay, thank you so much. I'll rectify.
Okay.
Yeah. Okay, guys, that's all for today. And give me half an hour or 1 hour. I will upload today video as well. So in the Google Drive, and whoever doesn't have the Google access, just you can ping me personally your email address so that I can provide the access. Okay, guys, that's all for today. Thank you so much and see you tomorrow evening.
Thank you, sir. Good evening
Good
and
night.
good night.
Good
Thank you.
night.